Hello, hello, hello. Welcome everyone to this next episode of the Julia Dispatch. I am Chris Rakakis,
And I'm Michael Thiemann.
and today we have a very special guest. I mean, okay, we say that every single time, but today we have a very special guest. It's Karandeep Singh. You might know him from building out he's doing the version of Tidyverse and Julia. So I would say he's one of our, data experts here. And so it'd be, I'm really excited to have him because he's really leading the way and really looking at what are new ways to be able to build interfaces and APIs that are more easy to newcomers to the Julia programming language for data science. So, Karandeep, would you give a full introduction to yourself?
Yeah, sure. Thanks, Michael. Thanks, Chris, for having me. It's a real delight to be on here after seeing the folks that have preceded me on this podcast and the folks that are on the slate still to come. So I'm Karandeep Singh. I'm an associate professor here at UC San Diego in San Diego, California. I am the chief health AI officer for UC San Diego Health, which means I oversee our AI portfolio for the health system, and then I run an academic AI lab within our Jacobs Center for Health Innovation, which is essentially a incubator and accelerator for AI and digital health within UC San Diego Health.
Yeah, that's great. And so, just to kind of for more of that, what really brought you into doing health sciences? Like, what made it into your calling?
Yeah, so I think I was actually writing software as a kid since I was probably 8 years old, learning a variety of different languages. And my dad was a computer scientist. None of my immediate family were in healthcare except for my uncle. And I think it was honestly a mix of volunteering in a health system setting in high school that really got me thinking about ways in which computer science could intersect with healthcare. That was something I carried with me through undergrad. And I would say, it's one of these things where at that time it wasn't a thing. And so it was really hard to find mentors when the thing that you wanted to do wasn't a thing. And so it wasn't really until even after med school and then residency and then in fellowship where someone finally put a name to what I was doing, which was health informatics, which is the kind of field of information sciences applied in healthcare. And so I ended up, in the middle of my fellowship training in kidney disease, stopping and doing training in biomedical informatics with mentorship. And I think that's a broad field. There's a lot that you can do. But I think my interest had always been in kind of software data and prediction. And so that finally became a point for me to really build that out as part of my career. And then I carried that on with me in my faculty role at Michigan, where we did a lot of applied data science work at the health system level, and that ultimately led me to this kind of role at UC San Diego.
And so, for someone who might not be as versed in the particularly in the US educational system, I understand you are a fully trained doctor, right?
Yeah.
At
so
this
I still
point.
see patients. Yeah.
All right.
So
Okay.
yeah. So actually, I practice primarily inpatient nephrology, which means I see patients with kidney disease at the health system. I haven't yet done my clinical rotation yet this coming year at UC San Diego, but for the past several years, 4 to 6 weeks a year, I practice medicine kind of on the hospital side. I don't have a clinic, and so most of my time is spent historically was spent running an academic research lab in applied AI, and now a lot of that is kind of a mix between research, but much more now with the idea of focusing AI and using it to improve our health system as kind of a core problem. And so much more operational role nowadays as compared to what I was doing at Michigan, but still, again, writing code, doing code reviews, running a lab, and still publishing and applying for grants and all the kind of activities that people would usually think of as kind of academic activities.
Yeah. So, but like those two roles. So you said you were programming since you were a little kid, but then you started off into healthcare with not as much immediate role models in your family. Like these two different aspects. Like, how did they combine in you? Like, was there one clear to your heart, or
Yeah, that's a great question. So early on, if you had asked me this question when I was a kid, I would have said I want to be a game developer. And so I used to read Dr. Dobbs' journal. I mean, I read like C++ source code for like ray tracing algorithms, and like that's kind of where my head was at as a kid. And so I actually,
What kind of games?
What kind of games?
Games.
First person shooters.
Okay.
Yeah, I mean, I like strategy, Command and Conquer. Like there was.
I'm StarCraft Brood War all the way still. So
There you go. Yeah. So like Zerg and Terran and like
oh, Protoss, come on.
Protoss, yeah. So I think I was not, but whereas some people really enjoyed playing games, and I enjoyed playing games, I was much more interested in how do they work under the hood, and so that was always kind of what I was interested in reading about. So I would read about like the Source engine when it came out, or like every id update to their like Quake engine and the original Doom engine, Duke Nukem, and like kind of 2.5 dimensional game development, and trying to write code for like TI-85, TI-86, TI-92 calculators. And so that was kind of my happy place for a while. Once I think I realized I wanted to do medicine, I never thought I was ever going to give up writing code. And I think when I remember talking to my parents about it, they were very much like, you can just continue to write code, just do it in whatever field you go into. Like, you don't need to write code for code's sake. And my dad had a lot of bad experiences kind of being purely in computer software, and kind of he was a auto hardware software engineer, and felt like that was just kind of not a good place to be. He was like, it's a much better place to have that as a skill set, but then develop domain expertise somewhere else. And so ultimately, I never stopped writing code. I mean, I wrote software in undergrad. I wrote software in med school. I wrote software in residency. I wrote software in fellowship. And so I think it was not something I ever stopped doing. It was more just something that I did really unmentored for a number of years, and didn't write any papers about it because that wasn't like a thing I was really familiar with. And it wasn't really till much, much, much later in my career that suddenly I realized, oh, this can actually be a career. It's not something that you just have to do as a side hobby. And so I think with better mentorship, it really gave me a sense of focus and direction. And then I think the last thing I really wanted was a sense of purpose of how can we use this not just to find important things in research, but to actually use it to change how we deliver healthcare. And that, I think, is ultimately what got me into this role. Is I love that I can now look at every, so there's people looking at like, oh, you can do this with LLMs, you can do this with prediction models. And I'm looking at it from, here's the list of problems that the healthcare system is trying to solve. And we've got this armamentarium, and really just, we need a workforce and a sense of like focus to be able to say, this is the right tool for that kind of problem, match it up. And so, what that looks like in a health system is I have data scientists, in our, cloud accounts writing software, and are, having an ability to run that software in real time on patients, and, on system level health system metrics, and try to better understand the care we're delivering today, and hopefully use that to improve the care that we deliver tomorrow.
Though, I mean, now this brings us kind of to our next point. I mean, one of the questions that you normally don't think that your doctor's thinking about is, what programming language do you use, right? So, but it looks like you started writing and committing in Julian 2022, right? Which is like in the middle of this whole piece, right? So if with this focus on the end usage for the healthcare and everything, what really brought you to change your fundamental tools, right? What brought you to be rethinking the tooling behind what you were doing?
Yeah, so this is an evolving thing, but I think I had learned a number of languages before I got to R and Python. I mean, I think going back to client side like JavaScript, ActionScript for Flash, and kind of ECMAScript, all those variants. I had done stuff that was server side like PHP. I'd done kind of visual interface stuff like Visual C++, Visual Basic. I'd done Pascal back in the day. And so I think for me, after going back and forth between R and Python, I'd actually settled on R for quite a while. And I felt like, whereas Python was really meant to be a general purpose language that could be used for data science, R was meant to be a data science language that could be used for general purpose. And so I was, once I kind of came to that realization, I had I launched my lab as an R lab, and all students in my lab, used R. We largely used, Tidyverse, because I think Tidyverse was just starting to evolve. It actually started with ggplot, and then a bunch of things kind of came afterwards that suddenly one day just kind of clicked. I was starting to teach a data science course on campus at University of Michigan, which was an introductory course to health data analysis in R. Originally, it was one of several R courses that were taught, but as kind of our course took off, some of the other courses went away and really just started focusing on Python. And so I felt like, I had this really kind of happy ecosystem in R, and a couple of things over time made me look at Julia a couple different times. But I think 2022 was a momentous time because Julia 1.8 had just come out. Mm-hmm. The feature set for 1.9 had just been announced. And so knowing that, pre-compilation was starting to become something that was a lot less painful, native code caching was something that was on the horizon, I felt like that was the time to explore. And I had messed with Julia many times. I played with dataframes.jl. I played with dataframes meta. I looked at dataframe macros, and I would always kind of get 50% of the way in and then kind of just back out and go back to my happy place. And I think somewhere there was where I really switched off of R into Julia. I still, in my lab, use Python because for a variety of just workforce issues and other things that make it technically a little easier to use when you're dealing with a diverse set of students and other folks who already come in with some level of knowledge. But my hope has really been that, as Julia ecosystem evolves, that we'll find a place to make that kind of, again, like a home for my academic lab and kind of beyond.
And we will in a second come back to this point of what the future looks like, in particular with having these diverse set of programming languages in the background. But let's quickly go back a gear and ask, what is a tidyverse for someone who has not heard of it yet? What is Tidier.jl? What's all about?
Yeah. So the Tidyverse evolved basically as originally just a single package known as ggplot, which was a fundamental rethinking on how to do plotting. This was a package written by Hadley Wickham. I want to say what might have even been part of his PhD dissertation work that, I think it was written before that, but I think he actually used some of that work and extended it during his PhD. But fundamentally, it took the idea from Leland Wilkinson's book of Grammar of Graphics and turned it into R code. And R is a functional programming language, which means that you can kind of chain functions together in a variety of interesting and unexpected ways. And at that time, rather than chaining it through piping, he chained it through mathematical addition and said, let's take different components of a plot, let's make them addable. And, for the first time you're seeing ggplot code, it was just not a declarative way of thinking, it was a functional way of thinking. And for folks who are in the kind of matplotlib and that world in Python, they would look at this and say, what the heck is this? But there was this fundamental beauty to this code because you could add things together. And when you wanted to modify it, you were no longer thinking declaratively. You were just thinking, oh, I want to swap this component out, add this component in. That might mean the plot looks completely different than it did before. Because fundamentally, the thing I've changed out is a geometric-like thing. Instead of using a box plot, I'm now doing, a violin plot, or I'm doing some other thing. But now you didn't have to think in the visual sense of the word. You could just think of the components of a plot and swap things out, and swap out that should map to a color instead of the x-axis. That sort of thinking had just not been around in kind of the usual data science languages. So I think when that came out, it was really attractive. And then gradually, very step by step, the rest of the data ecosystem started to emerge in a way that looked a lot like ggplot, except was driven by piping. And so there was originally a package called Plier, which was slow and kind of not very much more like base R than like anything that we see now. And then it got replaced by dplyr. And dplyr was this like epiphany of, oh, it's like writing SQL code, except instead of writing it in a way that's grammatical, like adding the word select first, you write it in a way that you actually want the functions to execute, and then you chain them together to get the desired result. And that meant that shortly after dplyr came out, there was no pipe in R, even though R is a functional language. So they had to introduce a pipe. And then, next thing you know, it's like, well, how do we reshape data frames, wide to long, long to wide? And TidierOrg, separate package, but TIDYR came out. And then really it just like kept growing beyond that. So suddenly it was, we have a tidy way to handle dates. We have a tidy way to handle strings. We have a tidy way to handle the entire machine learning modeling exercise where you can lay out recipes, and there was a tidy models ecosystem that evolved. And I think what was cool here was that a lot of people built add-ons, and they weren't add-ons that were merged necessarily into the main tidyverse or the main tidy models, but it just started to affect the entire ecosystem of R. Even forecasting was like, suddenly we have a tidy way to do forecasting. So I think it was one of those things that once you got into the really embracing the functional part of the R language and saying we can do it in this way that chains things together, suddenly everything felt like it needed to look like that. And so this entire ecosystem emerged. And I think what used to look like old school R base R code, which a lot of folks make fun of because it was really hard to unpack what was happening, because it was a series of functions that did like a dozen different things, but you had to know exactly which right function to use. Now it was like, oh, with 7 functions, I can write code that's data cleaning code that everyone knows and can unpack and make sense of. It's a bit more verbose, so it got made fun of for that reason. But I think that it got such widespread adoption that I think it really changed the course of R as a language. R really felt like a different language post-tidyverse than pre-tidyverse. And another critical thing that happened was that dbplyr came out. And dbplyr was essentially the same syntax as dplyr for working with data frames, but now that code works on databases, and they supported almost every database backend. So now suddenly people who learned R and had never learned SQL, in my course, I would tell them, honestly, you don't really need to learn SQL. For the 80% of the things that you want to do, you just write R code, and you have that, R code convert your code into SQL, run it on the data frame, or run it on the database, return data frame, and now you continue, futzing with it in R. And so I think the ability for R to become kind of that duct tape that connected all this stuff together, and really a true glue language, and kind of have that aspect be embraced, is I think what led to that being kind of so popular. And so what I felt like was missing when I was looking at Julia is Julia has this really rich, macro metaprogramming system. And there is a real ability there to make code a bit more accessible, where the options of what a user would want are fairly limited, but the options that Julia gives you are quite diverse. And so by removing some of those options, by taking care of some of that burden off the user and is into the internals of macro-based programming, you can essentially implement a domain-specific language. And I kind of had this epiphany when I was, Julia 1.8 had come out and 1.9 came out, that, hey, I could just re-implement tidyverse in Julia. And I never really thought I would get super far, but I said, let me try and just see, is this even doable? And so I started with strings, and then kind of very quickly backed my way into abstract syntax trees, and walking through and modifying expressions, which I had done in R, but now I was just doing in Julia. And then realizing that, even though Julia lets you have this lower level of programming that you can do because it's it's meant to solve the 2-language problem, there's going to be a role for that more abstract level. And I think in data frames, what I felt like is that abstract level was sharing philosophy with the lower level. And I wanted to break philosophies and say the lower level should have one set of philosophies, and the abstract level should really be much more user-friendly. So I took tidyverse as a blueprint to say, even though I don't agree with all the decisions that are made in tidyverse, it is a blueprint that works. And it would be nice to bring that blueprint over to Julia and get the performance benefits of Julia while having that kind of consistent syntax for really all things data in the macro space in Julia.
And so is it now in a point where the people who are familiar with the R syntax, Tidyverse, they can literally use Julia with the exact same syntax, maybe besides from importing the package or something?
Yeah, so I would say it's almost the exact same syntax. You'd have to teach them how to do pipes, which involves the chain.jl package, which is slightly different than the pipes that they're that like they might be used to with the Tidyverse pipe and the new kind of native R pipe that was added after the Tidyverse pipe as a way to kind of backfill that lack of functionality in the actual language itself. And then you'd have to show them how, like, what is the @ sign, and like, oh, that's a macro, and like, here's how macros work. But I think that someone who knows Tidyverse code would look at Tidier code and say, that looks nearly the same, if not identical, to what's there. So that's, I think, where we're at with maturity level. There's probably some really, kind of edge case things that people can do in Tidyverse that still aren't supported in Tidier. So I don't think we've gotten 100% feature parity. The other thing is that Tidyverse is a rapidly moving target. I mean, they've taken some heat for soft deprecating and superseding certain functions. And so there are things that work in Tidyverse code one year that are technically not the like cool way of doing it the next year. And so we've tried to adapt to that and really target kind of mostly the most recent functionality, but in some cases the most common functionality, in terms of the flavor of Tidyverse. But yeah, I would say there are people who've publicly said, hey, if the following like 14 packages from R existed in Julia, I'd switch over. Well, I would say all those 14 packages are there.
Yeah, I mean, I know those people, right? I have a background in pharmacometrics, and actually for years, a lot of the pharmacometrics community would tell me, I'm not a programmer. I don't know R. I use Tidyverse, right? And that's I've always found it to be an interesting statement, right? Because it's just like, well, you are programming in R, right? And it's like, no, it's being used as a calculator, right? It's like this higher level that, they like how you say, like, there's different levels in it when using programming languages. And, these folks would talk about it as like, no, I use Tidyverse. I'm not a programmer. And so, yeah.
So they'll do a group by summarize function, right? Where you aggregate by a column and you summarize by another column. They're effectively writing a for loop, but they're not writing the for loop. They expect that to be, kind of abstracted away from them. And so that's the, like, I think target audience of Tidier is folks who want to abstract away their for loops. It's not that they can't write the for loop, because Julia will happily compile it and give you kind of an abstraction, but it's kind of the things that would have been 10 lines of code or would be one really unreadable line of code, and making it a lot simpler. And there's complexity wrapped in the simpleness, so you can't completely escape from the complexity. But I think we've done a reasonable job of trying to make smart decisions about how we abstract that away while still giving people who need that fine-grained control access to have it. And because it just functions interchangeably with dataframes.jl, you can go back and forth between the two paradigms as you wish.
And now that Tidier.jl exists, I mean, so I took a brief look at the talk that you've also given at JuliaCon last year, and it seems like every major language has a Tidyverse implementation. So what would you now say are the pros and cons, or what would be the rationale to choose Tidier.jl in Julia specifically over the other implementations?
Yeah, that's a great question. And for folks who are listening who may not be familiar with this and haven't seen the talk, there are probably at least a dozen implementations of various Tidyverse packages in Python. So even just dplyr, the main kind of data frame manipulation one, probably the most high profile Python package is Ibis, which was written by Wes McKinney, the same guy who wrote Pandas. He no longer maintains it. It's maintained by like a whole group now. But the Ibis framework is essentially dplyr plus dbplyr in Python and kind of fully implemented. There's another package, Cuba, there's PlyData, there's dplython, and even ggplot has an equivalent called plot9, which is nearly identical syntax to ggplot, but in Python. So I think people will often say, oh, you're bringing R thinking to Julia. And I say, no. Actually, Tidyverse is like as far from base R as you could possibly be. Base R people will look at Tidyverse code and literally not know what to make of it, because it's all macro meta programming magic. And so it's really that metaprogramming magic that I'm hoping to bring to Julia. So I think the question that you asked is, why would someone use this in Julia? And I think, like many other things, I don't think this is going to be a sole reason to use it. I think where you might use it is that it brings you speed that you might not have in R. But that, I think, is increasingly less relevant, because in R, many people who wrote tidyverse code are now writing duckplier code, which is literally dplyr code that runs on DuckDB, where their code gets converted to SQL, runs on DuckDB, and so they see the benefits of DuckDB. Or there's code that converts tidyverse code to like polars, and so I think that largely the backends have been abstracted away, and I think R, because of the popularity of tidyverse, has like dozens of backends that you can use where the same identical code will work on a database that would have worked, or on DuckDB that would have worked only previously in an R data frame, with kind of some of the issues of the R language trying to be, do too many things there. So Dataframes.jl is a great engine to build on. Maki.jl is a great plotting engine to build on. And so I think what we very much did early on was I reached out to Bogomil Kaminsky and said, hey, I'm thinking of creating this new thing that will wrap Dataframes.jl. Do you have any advice for me? He said, well, check out the existing things that are out there, which I had played extensively with the existing things that are out there. And I said, but he kind of gave his blessing to say, yeah, build on it. We want people to build on this as our kind of engine. And I did it, as a courtesy, I did the same thing for the Maki team. I reached out to them and said, hey, we're thinking of using this as a base kind of under the hood engine for what we're going to build tidier plots on top of. Any concerns or any issues you would have. I know you guys have algebra graphics, which is great, but it brings a very Julian kind of approach to it, where you can do addition and multiplication, which adds a layer of, I would say, complexity. It adds a layer of elegance, but the elegance comes at additional complexity that you have to understand and unpack. So we said, I hope this is not viewed as competing. And said, go ahead and build it. And so I think that to answer your question, I would say you need other reasons to be in Julia besides just this. I don't think people will come to Julia just for the existence of Tidier. But my hope is that if Tidier is there, then it's one more kind of core building block that will get people into the language that otherwise might not have considered it. Or think of it another way, if there's a package that's in Julia that they really want to use that relies on data frames, this gives them an accessible way to work with that package without having to now sit and read and understand, the kind of very elegant, but again, Julian syntax that Dataframes.jl has.
And you're giving a lot of credit to, like the big tidyverse and all the things that it had done and everything. I'm kind of curious, if because there's always something new added, right? There's always some new idea. So is there anything that you point to be able to say like, oh, but we did get this cool new feature here in the Julia tidyverse?
Yeah. So I think the cool thing is you get the benefits of Julia in Tidier. And so I think that's a strength. So as an example, in R, if you have a function that operates on a vector, that function can either return a single value or it can return multiple values. There are no scalars in R because everything is a vector in R. So if it returns a single value, it's returning a one value vector. So an example of this would be like a mean. If you calculate a mean of a vector, you get back a single value that contains the mean. There are times, though, where your data is nested, where you actually want the mean function to be vectorized over, like a nested object. And in R, you'd have to use lapply. You'd have to now build that additional layer of abstraction on top of R, maybe define a separate function that does that. And what's cool in Tidier is that if you vectorize something that we would normally consider not to be vectorized, we let you do it. And so you can mark things as needing to be vectorized. You can mark things as not needing to be vectorized. The nice thing is that we kind of handle the intelligent defaults for you. But if you want to tweak it, you can just add the dot and do dot vectorization, and you get the benefits of kind of Julia vectorization without having to resort to kind of our way of thinking. So I think if you're an R user entering the Julian world, you would be like, oh, I don't have to do lapply. I don't have to do sapply. I have this kind of, I can just let the language take care of that. So I think that's like some of the things where I think, where Julia is kind of cool. I think we have tried to make it Julian in certain ways. So ggplot started off, the tidier plots package started off as a macro-based package. And then we realized, even though we needed macros in tidier data, because we do a lot of post-processing on the expression that you give before we convert it into an expression that DataFrames.jl understands, there's a lot less of that in tidier plots. And where there is that, it's actually constrained to really one space. And so we realized we could implement that entire package as functions. And what's actually really cool about the dispatch in Julia is that in R you historically had to do plus when it came to ggplot. Those elements had to be added together. You couldn't pipe those. And because of multiple dispatch, I said, well, in Julia we should support either syntax. You can add plot elements together, you can pipe them together, and because the method signature looks a little different, we can on the fly convert one to the other. And so what's, I think, new in Tidier that isn't as holistically supported in Tidyverse is a complete interchangeability for Tidier plots to do addition versus do piping, because it's largely used the same way. And Hadley Wickham is on record saying, hey, if I could go back and rebuild ggplot, I might have rebuilt it with piping at that time. But the cool thing with Tidier is we can just support both. So you can do either one because the language lets you do it.
Yeah. I mean, that's pretty cool. I think it'd be really interesting to, create a style guide for it where you say, okay, the cool kids all do this where you do a plus and then a pipe and a plus and a pipe. It's just one after the other just to kind of show off.
Yeah.
Also, as I'm guessing, Chris, your mind also went immediately to the style guide badge on GitHub, like using TidierJL style guide.
Yeah, we intentionally didn't adopt any of the existing style guides because I was like, I want to see how this plays out. One of the things that I had kept was that a lot of my code has 2 spaces for tabs rather than 4. To make it more mobile friendly. To make it more mobile friendly, because I actually I used to exclusively write code on my iPad, and so I don't now. But at one point I've written entire software packages like on my iPad, and so I was big into like having that. And in R, actually, I think 2 spaces was the norm, whereas in Python and Julia it's 4. And because of all the piping and like nested piping, if you do 4 tabs, you quickly get to the right side of the screen. And so I think there are places where I think we haven't like firmly adhered to something, but I also didn't want to slow progress. So I said, we will fix this style. We will harmonize on style later. Let's get it working and, make sure we have a product. It can be the most, nicely stylized product, but if it doesn't work, no one will use it. And I think largely to some extent today, I think there's the question isn't so much for our users adopting, Julia, what they would use. I think a lot of the, kind of challenges facing our Tidier ecosystem is, what about the Julia users who are data users? What's the compelling argument for them to use Tidier? And I think the main one there is we've tried to remove just a ton of friction in a lot of different places. And that's why you'll see we've got functions to handle timestamps. We've got functions to handle strings. We've got functions that handle, sure, they handle plots, but, it's the kind of everything working together is what we're trying to solve, because I think Mach-E will always have a different philosophy to some extent than DataFrames.jl. And that's okay, and that's healthy. And I think what we're trying to do is to see, it's all, can we get more of a consistent philosophy across the ecosystem, even reading files in. I think the, file IO package is great, but it's not just for tabular data, it's also for images and other things. And so what the consequence of that is that you actually need to learn the function-specific arguments to effectively read a CSV versus an Excel file. And so we said, okay, well, in our ecosystem, those 2 things are the same thing. Yeah, there are sheets, there are like some different parameters, but 95% of that should be shared arguments. So like in Tidier files, we implemented essentially the same set of arguments almost no matter what the backend, as long as you're dealing with tabular data, which is a key constraint we add, which FileIO doesn't have, but that I think, again, is as long as the underlying packages work well, we will take the responsibility of making things map and work. And I view us as essentially a big, kind of syntactic sugar force to try to, make some of that stuff work. We're not solving the technical challenges. We're solving the syntactic sugar challenges.
So this brings up a interesting question that might be somewhat of a devil's advocate question, if you will. So in my experience, there seems to be a divide between, let's say, disciplines backgrounds from what sort of ecosystem people use, right? So machine learning seems to be dominated still by Python, and then obviously they tend towards the names of the big machine learning ecosystems, let's say PyTorch and TensorFlow and JAX. There's people with an engineering background. Many of them use MATLAB first, and some also use C when they really get down to the machine level. And then I personally associate R a lot with like health sciences, psychology, medicine, maybe also some other life sciences, statistics, exactly. So, and now you also have the same sort of divide within Julia with Flux and SciML and Tidier. Like, what is your personal view on how this sort of multitude of ecosystems exist in parallel, but also maybe where do they connect, or how should they connect, or how should they interplay with each other?
Yeah, so I think Julia is a functional language, but if you look at what ecosystems have involved, some of them have been driven purely at like a Julian approach. Some of them have really are offshoots of stuff that was in Python, and there are things that are offshoots of like philosophies in R. So I think in my mind, it's healthy to have multiple kind of ecosystems available for people to get into the language. And I think, but I will say that, there are things where I look at it and I'm like, ooh, that was implemented in a much more Pythonic way in Julia than like an R way. And an example I'll give you is MLJ. MLJ to me feels a lot more like scikit-learn than like tidy models. And that's nothing, it's not a criticism. It's just saying that I think there's going to be room for different sorts of things. I mean, I know even with like Lux and Flux, there's some differences. I think the main challenge of having multiple ecosystems is the number of users and developers and maintainers is limited. And so to some extent, you'd want to say, hey, hey, everyone, put your effort into this one thing, because you might get more bang for your buck as a language. But people, I think, will do what they're passionate about. And so you can't actually get people to do that. And the result of that is just, I think, death by 1,000 rough edges is, I think, sometimes what happens in Julia. So as an example, there's a metal.jl package, right, which supports metal. There is a set of kind of GPU manipulation things, and then Flux that supports, using GPU capabilities of Julia. But if you want to do a convolutional transformation, Metal doesn't support that yet, metal.jl. And that's like an open issue for a long time. And there's like little stuff like that where if you wanted to play on your MacBook, you'd say, ooh, I can install Flux, I can do this, and let me do kind of an image network. And then, oh, it doesn't work. And so I think there are those little rough edges that I think is the consequence of that. So I think it's a chicken and egg thing. That if we try to make Julia as kind of the main entry point for the language, multiple ecosystems may hurt, in some cases may help, and it will really just depend on how mature they are. People will debate this for Mach-E and Plots, right? Like those are both pretty mature ecosystems, and while people will have views on which one is the future, quote unquote, there are active users of both, and so you have to kind of just come to terms with that. So so I think it's an issue. I think there is a future once we have static compilation with static linking, where we will see Julia as potentially a competitor to Rust as a backend language, where you make the front end available in Python, the front end available in R, and you're largely taking advantage of the speed benefits of Julia in code that looks easy to read, and kind of you can work at the higher level of abstraction if you want. So that might be, I think, in some cases, the near term happy place of Julia for at least a subset of folks whose world, for a variety of reasons, is pulled into either R, Python, or elsewhere. But I think, I feel like just like Julia 1.9 put us on the cusp of like, ooh, now it became fun to use the language as an end user because you weren't waiting on, all of these data science tasks. It was really silly to show someone the time to first plot problem when you're like, wait, this is a data science language that takes time to plot data, which is the one thing it's supposed to be, fast at doing. And you have to explain them. Well, there's like, it's really fast the second time and great for production workflows, but not great for exploration of data. So I think we solved that issue with 1.9. And I think with, some of the recent commits happening with, the trimming capability and, and some of that switching from dynamic to static linking, I think we're on the cusp of Julia being a great backend language that's easy to package. So I'm really looking forward to that day. I think that's still really clunky today. But I think that will make it like available to a whole new set of users.
Yeah, and there's always so much that's coming. I do kind of want to drop the hint here. I wonder if it'll be actually out before the episode goes up. But yeah, there's also a lot that's going on in terms of escape analysis. So that way, small allocations and such will automatically be deleted and removed to manual malloc freeze inside of functions and stuff. So yeah, the language, kind of existed in the state of like Julia 1.0, where it's just like, yeah, if you write the right Julia code and you're willing to deal with the time to first plot, then you're good, right? And so over time, it's just been getting relaxed. And yeah, I think that once as these kind of limitations got relaxed, then it's just like, okay, now people who are not willing to, not trying to just build like a HPC kind of application, now those people are kind of looking at the language to be like, oh, could I get the performance right away and do this? And it's like, yeah, but we're really focused on these hardcore, okay, the SciML university, can we try to make things as easy as possible? But our interfaces come more from like, the C++ and Fortran world, right? With multiple dispatch, we do a lot of nice, Julian things like that, but, we're really targeted at, being these core utilities. So it's really cool to kind of see people now kind of come into this and just say, hey, look, there are nice reusable utilities, data frames, the SciML ecosystem, and all these different pieces. What can we do on top of it to make it so that way things are easy to use for newcomers who are, want 90% of the speed, but also ease of use, right? And so I think that the Tidier is really kind of coming at the right time with, the different flows of what's being added to the language.
Yeah, and I'll just say real quick, literally, I think December of 2022, read the Julia manual like cover to cover, and then wrote Tidier like in 3 weeks. So it was like that was my entire exposure to. I had seen the language before. I was just waiting for like the time to first plot problem to be more solved. And I think when 1.8 came out and 1.9 was announced, I said, okay, let me just use my winter break and just like read the manual. And I didn't skip the metaprogramming section like a lot of people do. And so that's where I love metaprogramming. So that's where I kind of focus my effort. But the other folks who've developed it, Randy Boyce, who wrote Tidier plots, again, new to Julia, had never programmed a line of code in Julia until he wrote Tidier plots. Daniel Risk, who is a medical student mentee of mine, came to me one day and said, I have written the equivalent of the stringer package in R, Lubridate in R, and Forcats in R. And I said, wait, I just introduced you to Tidier like 3 weeks ago. When did you do this? He's like, in the last 3 weeks. I said, but you didn't know Julia until like just 3 weeks ago. You didn't even know like what it was. And he said, I know, but what I did was I actually started ChatGPT and I explained what I was looking for. And I just kept messing with it until it produced code that worked. And that's literally how I think several of like his packages started, where now he's much better. Now he can spot issues. And now he's like, kind of a functioning like applied Julia programmer, in kind of brilliant at problem solving. So that's not to say like, he wasn't brilliant. He was brilliant all along. But from going from nothing to have 3 packages written that are legit individually Tidyverse packages in 3 weeks was possible, I think, in part because of ChatGPT. And so when people were like, oh, is this something that you think embrace or not? I said, Tidier wouldn't exist without it. So I think that while it's not where I came from and, all my stuff is like handwritten to be like, as efficient as I can, it's a really helpful starting point to start with something and then to optimize, discover edge cases, add test cases. And I think that kind of, yes, it can introduce correctness issues, and we've gone back and fixed stuff. But I think, learning doc strings and learning that itself has actually fixed a lot of those things. So just to say that I think it can be a language that a newcomer who only knows maybe a little R or Python, or in some cases no programming, is coming into can deal with. But I think the coming from knowing R to learning Julia, that ramp and needs to be as narrow as possible, because I think once people make that leap, it's not that hard to start to understand some of the more complex things that Julia can do. So that's where I think where there is a user base, that's a potential user base that exists today, that I think if we only think about the folks who are Julia users today, their needs will be kind of very different than the needs of that much larger, I think, potential user base that could be using Julia today, if only they had kind of their favorite package or tool in the language, and could see how much faster it is at a lot of the for loopy hack together code that they're using today, which isn't C++ optimized.
Is there a tidy differential equations version? Like, is there a tidy differential equations package in R, and is there like the equivalent in Python in Julia?
I'd actually have to look in R. So I actually don't know. You could Google it, or my Google search right now is a ChatGPT search, but you could.
I think Chris is.
I'm looking at it right now. I don't think that is the case, but I mean, it'd be interesting.
But I think but there are tidy stats packages. So people have taken. So you take the strength of the language and you tidyify it. That's actually happened quite a bit. Although people are careful to do that, because that's where like base R code is tried and tested. You don't want to mess with it. Is situations like that. So I think in Python we're seeing a lot of method chaining as kind of approximating chained operations. And in R, there's very few method chaining. It's all free functions that you can, interchange and compose together with different arguments that just all work. And I think, Julia, I would say, is more R-like than Python-like in that sense. And yet a lot of our code base looks a lot more like Python than R. So I think that's where, in my mind, some of the opportunities are, and why we're seeing, I think, Chain.jl take off in a lot of places where people historically have been hesitant to show chained, like a chained Julia code. It's becoming much more accepted to just do the chain and just show it that way.
Mm-hmm. I mean, I will say that one of the interesting things about that user base that you talk about, right, which I actually didn't really think about it that much until last January. I was at a workshop where I had to kind of do a bit more data science things that I'd done for a while, right? My data is not data science, and so I decided at the time, I saw a lot of the stuff that you're doing on Twitter, and I thought, let me just pick up a little bit of Tidyverse, right? And boom, you can now call me a Tidyverse user. Like I'm not the data science person all the time, but I was like, I'm a deep into the Julia kind of person. But then the moment it was like, okay, I need to figure out how to make this database from this file work and this one work and this one work. I was like, I don't need to worry about making sure I get all like. Let's try this Tidyverse thing, and then boom, I had it all together into the arrays that I want, and then I was like, okay, numerical linear algebra. I'll write my own blogs on this stuff if I have to, right? That's what I'll do. But it's like it was so cool that I was just like, okay, there's also this user base of like I'm not learning Julia, but I'm learning parts of the data.
Part of Julia. You're entering that department and saying, do I need to read 3 books before I can do something, or can I dive in? And I think that. There is a learning curve to Tidyverse-like thinking, but I think it's a lower learning curve for folks who know Julia because they're already familiar with the concept of chains and pipes and functional programming. So I feel like it comes more naturally than having to learn kind of bespoke syntax. The bespoke syntax is so elegant, and I love it, and it gives you all this capability. But I think that what you want in a higher level package is you minimize the time someone has to fall back to more complex, lower order syntax. Yeah. And one thing we made that was a design choice was, whereas some of the other meta packages have certain complex situations where they say, oh, here, just default back to using the kind of native data frames.jl syntax. I said, I want to minimize the times where we would ever make that recommendation, especially if there's a mechanism to already do that in Tidyverse. We will make that mechanism, exposed and easier to use.
Mm-hmm.
So that's great that you were able to pick it up.
Yeah, I mean, I mean, I know what you mean by, not defaulting back down to the data frame kind of syntax, because I remember some of these things I've looked at before. It was just like, I get this thing in data. I want to just get to here, how do I do this, right? And then, you might have someone just say, this is a, select group by, I'm just like, man, I could probably figure it out if I want, but I just haven't. I don't use those primitives very often. So they did, but then it's just like, at filter, filter the data frame for this, and then put this right next to it. Oh, hey, it worked, right? So it was really cool, yeah.
And the best part is, in my mind, the most underrated package in all of Tidier is TidierDB. So that's where you take your regular Tidier data code, literally just swap it out with TidierDB as the underlying package that you're using, and all the macros, you use the same exact macros and almost literally the same exact code, and it will translate it to whatever flavor of SQL you want. And it supports, I think, over a dozen different flavors of SQL. And this is something that I remember talking at the first. So I've only been to JuliaCon once. I went to the one in Boston in 2023, and then Randy gave a talk on Tidier plots at this year's JuliaCon. But I remember talking to to Bogomil and some of the tables.jl folks and saying, is there some way that at a tables.jl level you could make it so that data frames code gets abstracted to SQL? And it was like, maybe, but it's really tough because when you vectorize or don't vectorize, SQL doesn't have easy ways to handle that. And to me, having used dplyr and dbplyr, I was like, well, you can easily abstract tidier style code to SQL. It's already kind of SQL-ish in its format. You just have to understand some of the different variations on SQL. So we actually originally thought about wrapping dbplyr and saying, why don't we use dbplyr R package just for the SQL generation part of it? But I gave this challenge to Daniel Risk, who was a medical student. I said, see if you can figure out how to generate SQL and do it for as many flavors of SQL as you can. But first do it for one, get SQLite working, and then we'll kind of go beyond that. And again, one of those things where 2 weeks later, he's like, I've got it working. And I was like, do you really have it working? And he's like, shows me. I was like, oh, this actually works. So we iterated on a whole bunch before we kind of released it. But right now, it's almost a drop-in replacement. And so I would say, for someone like you who understands dataframes.jl and suddenly now has to deal with that same data sitting on a database, you essentially can not modify your code and have functioning, primitives that work on on databases.
Yeah, I think it's just such. I mean, there's a cultural element to programming languages as well, right? So one of the interesting things about Julia as a programming language is that you have people from R and Python that kind of come from these high level languages. But you also have a lot of people from the C, C++, Fortran world, where it's just oh, you're hardcore, right? And so sometimes you have a lot of people that just be if you are hardcore, then you got to do hardcore things, right? And then it's just I get to a problem that's just databases. That's just I don't work with databases often. I don't care to do the hardcore version of it. Could you just help me out? And it's cool that there's now these utilities which are able to do this in really high level syntax, but also it's really not losing that much performance from what I can tell. I'm still hardcore enough to go profile afterwards and be like, wait, how well did I get? And it turns out pretty good.
Yeah. So I think my main message would be to people, right, is Tidier is not borrowing R and putting it in Julia. It's borrowing something that is agnostic to language and making it available in Julia. And that thing took off in R, but it's in every place you look. I mean, there is Tidyverse for JavaScript. It is not. It is. If there's a language that exists, someone has tried to implement. I think I ran across Tidyverse in Scala. So you cannot come across a language and that might be used for data and not see someone try to have implemented something akin to Tidyverse in it. So I kind of think, a lot of the kind of really folks who are early adopters of Julia kind of sometimes that, kind of phrase against the kind of traditional Julian thinking of well, this is the Julia way of doing XYZ task. And I think there always will be a lower level way of doing it, and maybe a couple different higher level ways of wrapping that lower level code. And I think, it's really honestly up to people, but I hope that what people take away from this is that if I try Tidier, I'm not a convert to R, because that's actually not the message I want people to get, but rather that you now have an ability to do things across a couple different Julia packages with consistent syntax. And if you're someone who doesn't need to be deep in the weeds of working with data frames and Mach-E, maybe that's an appropriate level of abstraction for you for all, or maybe even 80% of what you do, with the ability to always fall back, because we've carefully designed all of our ecosystem where it adopts interplays with existing packages.
So I want to gently move us towards the future, if you will. And maybe one way to combine the present and the future is, you mentioned there's a lot of metaprogramming going on. And I'm assuming that there's like the whole Tidier ecosystem makes heavy use of macros as well. I have not played with macros too much in Julia yet myself, but from what I heard is that there's a lot of like macro hygiene, and programming with macros is not as easy as using like no macro code. Like, what was your experience, and maybe like, is there like something that specifically from this aspect of developing Tidier you want to take forward to Julia maybe?
Yeah. So I think, Julia is pretty powerful when it comes to macros. There are a lot of different macro convenience packages. I think the base packages in Julia, like just base macro capabilities, are a little bit painful to navigate from walking across the abstract syntax tree. I use a lot of macro tools as my kind of building block, but there are many other kind of more modern and other ones that people use. But I think the key thing with macros is that there are a lot of blog posts and a lot of different resources, but I have been wanting to write like a definitive guide to macros, which is kind of like having written this package of like the different kind of ways that you need to think about code differently when you're dealing with macros as compared to not macros. And so an example I'll give is this. In macro-based code, there is two areas where code lives in a macro. One area is outside of the quoted function before, and then the second area is inside of a quoted function. Outside of the quoted function, you can manipulate the expression all you want, but you can't peek inside it to see what it is, because that would require doing an eval, which will immediately put you in a bad place. Inside the quote, you can you can look at all the things and instantiate them and see what they are, but you can't now go back and modify the expression. So if you have situations like where you need to look at an expression and depending on what it is to modify it, you're kind of toast. That's one thing Julia doesn't do. And I think it doesn't do it intentionally because it can't optimize that code. If you had to peek inside of an expression and then modify the expression as a result of what's in it. That kind of concept is kind of taught in a couple different places, but I haven't seen it like really cleanly expressed. People often share by example of like, hey, if you wanted to access this variable sitting here in this location, here's how you would do it. But the bigger question is like, how do you write a macro in the first place to, like, where do you put stuff? And so writing Tidier really got me really a better understanding of, okay, we need to like, do a lookup on what function this is. And if it's this kind of a function, we generally don't want to vectorize it unless they vectorize it. All that stuff I do upfront, where I'm looking at functions as basically symbols because we're, doing a post-walk walk over the entire kind of expression and using the capture macro, which is really helpful to see whether there's kind of matching of code that you want versus code that's there. So I think it's one of these topics that it's a little bit of a daunting topic. Like all the things I've read have do a reasonable job of like explaining the mechanics of it. But I think the things I would love to see like in Julia at some point would be being able to support some level of dispatch on the object, not just the expression. And so an example I'll give is Tidier Data and TidierDB share none of their code because one generates SQL and one operates on data frames. But I wanted them to share names. And ideally, I would do some sort of like lookup of what this is and dispatch to the right like sub macro. Because I need to modify expressions in both places, it becomes like annoying to implement like recursive macros or macros with like a bunch of functions inside them that do dispatch. And so I think like that's the sort of thing where I'm like, that's where like you have to know what the limits of a language are from its like design. And I think that's one thing Julia is probably intentionally not designed to do. So
Yeah.
I think the thing is, I love to teach a course on macros. It's one of those things where I'm like, I don't have time to do it. And all the resources out there are great. I've loved a lot of them. And there's like a whole book on this too. But that fundamental point was something that took me a long time to like back into.
Yeah, well, I think I mean, the interesting thing with Julia's macros, right, is that Julia is a language that is JIT compiled, right? So it has a compile time and it has a runtime, right? So it really kind of
just ahead of time compiled. I thought this was like a party line.
Yeah. So the interesting thing with a macro is, right, you're basically saying, hey, here is a piece of Julia code that I want to move to that compile phase, right? That is going to run on other code to generate code that will then be running at runtime, right? And so I think that there's always this interesting thing, like programming is all about models at the end of the day, right? And so like it's just like the thing that I think is interesting with metaprogramming is like in Julia in particular, which I don't think you kind of have in some of the other metaprogramming language, is like Julia has this split between what is my compile time and what is my runtime, and macros really kind of force you to understand that model, and and you have to be able to say, oh, this value exists at runtime, this value exists at compile time, so like they can't look at each other, right? And so I think it'd be really nice to really see someone kind of go through and do a full dive into here's really the essence of how to think and understand macros.
Because in R, you can do both at the same time. You can modify the expression and peek at the value all at once. And so I think people coming from R would, like, I think people from Python, I think they're not used to generally thinking about the abstract syntax tree at all. I mean, there's some level of like decorators you can use in Python, but they're pretty rudimentary compared to what you can do in Julia. And I would say in R, you can do a lot, but it's kind of dark magic. You don't know for any given expression, is the expression being used? Is like, it's very opaque to the end user, which makes it really user friendly until something doesn't work, and then you have no idea what's happening.
I mean, I remember, the plotting functionality in base R uses that, right? Because it finds out what is the name of the variable that you passed into the plotting function in order to automatically put the label on the plot, right? So it takes metaprogramming many ways. Yeah, but and then Julie kind of lives in this like middle ground, right? It's almost like a C pragma, right? For the preprocessor pragma for like, do this before you run the code kind of thing, but in a higher level language. So it almost it lives in this interesting middle ground there. But it's a great topic. I could talk about it forever. You could probably go.
It's been fun for me to learn, and I think that it's been one of these things that's what made TidierOrg possible. And I think I remember when I first asked somewhere on GitHub. Rewinding real quick, before I wrote Tidyverse, I actually wrote a small package called TidyTable.jl, which wrapped actual tidyverse in Julia. So it was kind of funny because I was like, this is like solving the 4-language problem. It's like wrapping R, which is wrapping C++, which is wrapping C, which is like so it was kind of almost like a completely backwards thing. And so but I remember describing, well, I want to do this natively in Julia. Like I've shown you it's possible if I wrap R and I just like do it with R. And I remember someone replied, you can't do this in Julia. You can't decide based on the function whether or not to vectorize it. And I think I almost took that as like a personal mission to say, there's got to be ways you can. And I asked around to several people, and they're like, that's not what Julia is for. People said you can't do that. I know with macros you can do cool stuff, but you can't do that. And I just said it's got to be doable. And so I remember, it was almost like learning metaprogramming by brute force because of like being told you can't do this. And look, none of the other macro packages do that. So why the heck would you want to do that? And I said, well, I want to do it. So don't tell me not to do it. Tell me I can't do it, and that's okay. If you actually can do it, don't tell me I can't. So that's what led to the existence of the original Tidyr.jl commit, was actually Tidy table getting feedback on that to say, like, this is not doable natively in Juliet. I said, I think it might be.
I see. So I understand how this works now. So I think it's impossible for you to make Tidyr.jl 100 times faster, and also GPU compliant. Also be able to compile the TPUs by the end of January.
It's definitely impossible.
The rest of the infrastructure, because all we do is wrap stuff.
So you mentioned you wanted to write a blog post about macros, but as far as I understand, there's also, you're currently writing teaching material for the Tidier ecosystem for new users, or?
Yeah. So, this has been a bit of a whirlwind year, because I, moved from Michigan to San Diego, took on this role in healthcare operations. And so I think earlier when I, kind of was in the transition process before I started to transition, I was like, oh, here's things I'd love to do, because I was really kind of more of a pure academic with some operational role, but I now obviously have kind of multiple things. So, so I think the reality right now is that there is someone from our kind of community, from Tidier Slack and kind of the other social media community, who is writing a Tidier book that is showing, I think, side by side data frames meta, and Tidier code, showing how you do the same thing. Now, a lot of the examples right now are taken from what is shown on dataframes.jl. And so in some ways, it's not highlighting the strengths of Tidier, it's just showing the stuff that's there. Whereas I feel like if we work backwards, there are situations I come up with really clean Tidier code that would be really painful and annoying to implement, or not painful and annoying. It'd be, you'd have to stop and think, do I vectorize that? Do I vectorize this operator or that operator? There's a lot of pairs based kind of syntax in dataframes.jl. So where I was going with this, I think, is that there are folks working on books. I've wanted to do it. It's not something I have the bandwidth to do, with really just understanding the gravity of the role that I have right now at UC San Diego, where I really want to make sure we move fast on that stuff. And to me, the tools have always been kind of a means to an end. I love the tools and I love the tooling. And so whereas some people purely treat tools as a means and they're happy as long as they get the end, I mean, I really like to understand the tools and to develop the tools that we then use to get to the end. So so I think documentation is something I'd love to sit and do, but I think that Tidybook at this point, in my mind, is a community effort. And I think if you look realistically, our adoption is still quite far behind DataFrames Meta. It's understandably behind dataframes.jl, because I wouldn't expect to that we would approach that level. And so I think the reality is that as community adoption grows for the Tidier ecosystem, I think it will infuse new folks into it who will help us take it further. But I think we've taken it quite a bit with just really a handful of folks, as I know a lot of the kind of efforts are. And we're still moving. So I think Daniel's still committing, stuff and still tackling PRs. And once in a while, I will, I'm doing that as well. And I'm vigorously tracking. Like I check my GitHub notifications every morning. And so I know what's being worked on, what's not. I weigh in on design decisions to make sure we're kind of staying true to our mission. But I think at this point, it's more of like a, hey, like Julia Summer of Code sort of thing. Like, come work on it. We're ready. We've got an ecosystem. But I also want to feel like we need a little bit better PR for the folks who are in the Julia community and just never have heard of Tidier. There's still, I think, a substantial number of folks who are in that boat or who've heard of it, but always just thought of it kind of as a side project. I mean, I would say it's a lot more mature now than it was even a year ago. And it's something that I'd be comfortable using for, day-to-day work in Julia at this point.
Yeah. And, and one thing I kind of want to, touch on here is that, I mean, you mentioned that, you're not able to, you're not doing the 20 hours of programming a day that you were when you're, because now you have an operational role. But I mean, that probably means that you have other opportunities, right? So for example, if someone is listening to this and they are interested in getting involved in, are you taking PhD students, or do you know other people who are working in the Tidyverse? Do they have labs that you're collaborating with that are looking for folk? How does one get involved now?
Yeah, so I think we have, what I tell people is join Julia Slack and meet us on Tidier channel. I know even there's like, other ways to other ecosystems for chatting in Julia, but I find Slack to be just easy, even though we don't have, super long histories of like retention, whatever. So I would say come there and introduce yourself. And usually we will, find you stuff to work on. In terms of PhD students, I am largely, because of my heavy operations role right now, I am largely co-mentoring PhD students with, faculty from, right now from actually our School of Management, but probably in the future, College of Engineering, and from our newly formed School for Computing Information and Data Science is where I anticipate that we'll have, kind of students. A lot of that right now is Python based, because I think one of the challenges is I don't want to spend 3 months teaching people the Julia ecosystem to be able to make progress. Operationally, we have to show that we can make a difference in our patients' lives and our clinicians' lives, administratively, clinically, as soon as possible. And so I think strategically for us, because there's a much larger workforce of students who have some background in Python, even though I ran an R lab for many years and taught an R course for, several years, we are now a Python lab for right now, at least operationally. But even there, we're not a pandas lab. So pandas is not banned, but it's highly discouraged. And we use kind of a tidyverse flavor of Python, but that's okay. But that said, I think that I am, really firmly still committed to the Julia ecosystem. And I think that people have always asked me a question, is it ready yet? And I remember asking that same question when Julia 1.6 came out, 1.7 came out, and then 1.8 came out. So I think that my goal is, hey, programming languages have these kind of, in some cases, exponential adoption at some point. But even if we don't see exponential adoption, if Julia becomes a great backend language for R, Python, and other languages, I think that's a huge win, because I have no intention to learn Rust. Rust is great, but I chose Julia because it's a garbage collected language where I don't have to, mark the life cycle of every single argument that I want to use. So there are people who love that, more power to them. I know Miguel Raz and other folks that are, from the Julia community are dual Julia Rust users, and we need people like that. But I also think that, when the right tooling exists in Julia for it to become a backend language to other languages, I mean, I'm going to flip to it instantaneously as a backend language for all kinds of stuff. And an example I'll give is I was trying to do causal forests in R, and that's implemented, halfway in R, halfway in C++. And so if I wanted to change a splitting rule, I have to change that in C++. If I want to change some other syntactic thing, I have to change it in R. And I want to get to a frame where I can just change the code in one place and it just works. But it's that kind of thinking that I think will only come when Julia is both available as a front end and as a clean backend language, without me having to say your first step is to install the Julia binary, as an end user. Whereas with Rust, most people don't even know that Polars is using Rust in the backend because they have it's abstracted away from them. So I'd love for Julia to be at a stage where it's usable as a first-hand language, but also it abstracts away enough that you can use it cleanly as a backend language with almost no drop off in someone even being able to tell that that's happening.
And for our potentially final question, I don't know whether Chris has more questions lined up, or I'm sure he has, but looking at the time. So you mentioned right now your lab is your students are mostly working in Python because right now you want to focus so much on the immediate improvement of patient care. So what would be sort of necessary to make the switch, or what is something that maybe people in the Julia community could contribute to make your life easier in improving patient care or like working on improving healthcare in general? Like, what is the big problem that you see that you would like the community to solve?
Yeah, I think the challenge there is that the actual solvable problems don't come down to programming. They come down to like other things and being able to influence them through, in some cases, artifacts that we built. And so I would say, from a Julia community standpoint, I would say build the things that you need, like solve the problems that you have in front of you, and where there isn't the bandwidth to do it, figure out a way to wrap things that exist in a clean way to make them easily accessible in Julia. I think people will point to like I look at prompting tools.jl as like a tremendous success, because in my mind that's a package that you use to work with large language models, abstracts away whether your model is running locally or running in the cloud on some API, and like a beginner can learn prompting tools.jl, whereas they would take like days or weeks to learn LangChain, because LangChain is like needlessly complex. And so people have almost like created Python simpler alternatives to LangChain, because, and part of the reason it's complex is that LangChain introduces yet one more pseudo pipe in piping syntax in Python that you have to like register the function and have it work, because Python doesn't do pipes. Whereas in Julia, you're like, why do you have all this kind of overhead just to pipe things together? You can just pipe them without any overhead, because the language will take care of that for you. So I think like there are things like that where prompting tools.jl meant that for many of my demos today for LLMs are still written in Julia, because it's just so much easier to bootstrap, something like prompting tools.jl. On the flip side, I think there is no real easy way to load like a safe tensors format into Julia package with kind of full support. And so if I was going to do neural network, even fine tuning, I haven't yet figured out an easy way to say, hey, take that off the shelf foundation model and just fine tune it in Julia without people pointing to the kind of usual, oh, look at llama2.jl and like, yeah, those exist, but that's not where the community's at. That's not where like, and so I think what I would say is the reason I think it's better right now positioned as a back-end language is that all the goodies that are coming out in the kind of deep learning, non-SciML deep learning and LLM space, the goodies are coming out in PyTorch. And they're being very quickly abstracted away in other Python packages, such that you don't even have to know about the goodies. You just get them for free. Like being able to do LoRa's and like all kinds of things, are things that you just get them for free. So I feel like even if we had a mature way to do this in Julia, we couldn't keep pace with all the publications and things coming out. So I think what we do is we make Julia as friendly to use as a backend language. And then I think that there will be things that now will show up in Python where someone actually implemented the painful part of their code all in Julia. And I think that will have a network effect. And so that's why I think that, from a community standpoint, solve the problems that are in front of you. Don't solve hypothetical problems. We see a lot of people posting on, discourse. It would be great if Julia had X. It's like, well, do you need X? No, I don't really need X. Does this person need X? No, I don't. I agree with you. Like, I love the efforts to build a game engine in Julia. It's awesome. I'm like a huge fan of like those kind of,
For
fun.
me, that thing is a self-hosted compiling. Yeah.
Yeah.
Like,
yeah. It would be great if Julia could do that. But is that what's stopping you from using Julia today? Probably not. And so it's kind of like people want like ideological purity out of the language where it can do everything for every use case. And I think
Julia, yeah.
Yeah, for Julia. And so I think it's fine. You'll never get that, but I think you have to look at it. And I think Jan LeCun, other folks have said, right, it would have been awesome if we would have used Julia out of the gate for some of the like stuff that's now PyTorch and where the backend code is in C++ or whatever. And so I think there's still some truth to that. But I think that, hey, wouldn't it be great if my causal forest package, I could quickly rewrite it in Julia and then just mess with it there. So I think we would see more of that. I really, truly think that that will be the next kind of, every one of these things has been gradually tackled. Time to first float made it a non-starter to do any other things. So I think now that that's tackled, and some of the other, huge binaries obviously makes it impossible to do anything once you have huge binaries. If you're packaging it in Python, where you're like, oh, here, have a gigabyte of extra stuff that you don't need. So I think we're very much at that point where, with that as the natural next step for Julia, I think better documentation, accessible documentation on how to do stuff is going to really pay off if we can make it a backend language. And then I think we need to be more comfortable embracing tools that come from other places. Quarto being an example. Quarto is something that now is natively supported in Julia through the Quarto, I think, notebook runner package. But like Quarto documentation, there's like all the stuff available, all these goodies you get for free if you have Quarto. And I think sometimes we say, well, this other thing came before it and it was a pure Julia solution. And just because this thing now is, some other thing built in it, we don't want to support it because of the methodological purity. I think that kind of stuff ultimately hurts rather than help. So I'm excited to see a world where, Julia code really works interchangeably with our Python code in a way that lets you build those artifacts faster.
Mm-hmm. Yeah, and I guess you heard it from him that I guess we need to really stop talking hypothetically about things we could do with Julia. We just got to get right back to coding. So, boom, fade to black. It'd be pretty cool if the episode ended right there. but we are. That is the end of the episode, I think. Though, Michael, do you have any other questions?
No, all that I think is left is say a huge thank you to Karandeep to taking your time. It has been an absolute delight learning more about Tidyverse and about the philosophy behind it and all things that relate to it. Just a big thank you.
Thanks, Michael. Thanks, Chris. I'm huge fans of your guys' and obviously excited that you guys are taking the responsibility and mantle of starting this forward, because I think sometimes, as users of an esoteric language, I grew up speaking Punjabi, and so people are like, oh, is it weird to use a language that like very few people know? And I'm like, no, that's how I grew up. So sometimes because it's not out there, I think people don't, it's just not in the kind of popular frame of reference and people talking about it. So kudos to you guys for launching this podcast and kind of reinvigorating, I think, the discussions happening around Julia.
Yeah. Oh, and thank you too for coming. So I hope everyone, the moment you turn this podcast off, remember, don't be hypothetical about it. Go download Tidier right away and just start giving it a try. So
thanks for listening.
Thank you.
See you at the next episode.